ProEstimate is an exciting project about a house price forecasting website. Whether you are an investor, home buyer, seller, or real estate professional, this project will be of great significance to you. Next, we will introduce our project in detail. The real estate market is one of the largest markets in the world. In this market, there are numerous players, including investors, home buyers, sellers, real estate agents, and developers. The complexity and diversity of this market provides us with a wealth of opportunities to meet the needs of different populations. As the global real estate market continues to evolve and become more complex, so does the need for reliable data and analytical tools. People need more information to make informed real estate decisions, and this is exactly what our program can meet. Our primary goal is to provide highly accurate real estate market forecasts to help users understand future trends and opportunities. This will help investors, home buyers, and sellers make informed decisions in real estate transactions. The needs of different user groups will also be met. Our target users are investors to help them make informed investment decisions based on accurate market forecasts. Buyers and sellers, providing data and insights to support their success in real estate transactions. We see our potential customers in three main categories: real estate data providers like Zillow and Redfin, data science and analytics companies focused on the real estate market, and traditional real estate agencies with a large market share. Even in this case, we still have a huge competitive advantage. We provide more accurate market forecasts, as well as innovative methods and technologies. Our goal is to outperform our competitors by providing high-quality data and analytical tools to meet the needs of our users. At this stage, the number of users of our system has increased significantly, and users can get accurate predictions, which indicates that our system has achieved some success. And we continue to receive feedback from users, which is very helpful for us to improve our products. In the future, we will continue to work on improving our technology to improve the accuracy of housing market forecasts, which includes introducing more advanced data analysis techniques and algorithms to better understand market trends. Expand our services to cover more regions and markets. This will allow more users to benefit from our data and analytics. Introducing more interactive features that enable users to customize their data queries and analytics to meet specific needs. In addition, we plan to develop mobile applications to enable users to access our services anytime, anywhere, and provide a more convenient experience. Next, we'll explain the techniques we use.
Now I'm going to give you a view for the core of the project that we have done for this, the model part. It is a prediction task, so I conduct a document to specifically discuss all the parts that we made. So in this scenario, we're interested in predicting a real estate property price. We conduct 10 models in this task, including the general linear regression model, rate regression, lasso regression, elastic net, decision tree, gradient boosting, random forest, general MLP, head rate, and SVM, and the BERT transformer. So firstly, we collect the data from new social valuation portal. It contains all the transactions recorded in the new social region in 2 decades, from 2001 to 2022. It's nearly 4 million data. However, different types of properties such as rural area, industrial building, units have different trends in pricing. So due to the time and cost, we finally choose only residential type of transaction. And only the price between 30K and $3 million data will be kept in our dataset. So the features contains the information such as the transaction date, property type, area, deal price, and so on and so on. We additionally collect the statistic information from Australia Bureau of Statistics and the crime information from New South Wales Police Force, and giving us additional data such as the average weekly income, average mortgage repayments, and employment rates, violence-related crime rate and the property-related crime rate. And instead of use the pre-trained model, we start from the sketch. We read some academic journal articles and the conference proceedings and giving us a lot of inspiration from that. And this is the analysis from the literatures. And this is the model explanations, the feature and also the feature explanations. And this is model explanations. It's describing some all the models that we used, like linear regression, the ray regression, random forest, about deep learning, the hybrid model, the BERT transformer, and also the distribution of the data set. And we also did the data processing, checking the relationship between each features and the linear fittings between some numerical features. And from the observation, we can see that we are encountered an imbalanced data situation. We use the log transformation to convert it into normal distribution, and it was better for the model performance. And we found that the macro data is more important for the model to learn the trend, to learn the pattern, such as the inflection, the crime rates, and the average weekly income, such as here. And here is the coefficients for the linear models and the importance for the tree design models. And in our results, compared with deep learning, the traditional machine learning technology can learn a detailed pattern from data, especially the random forest, with 96% of R squared and with only about 16% of deviations, which means that for each house, the deviation is about 13% of its own value. And here's the observation of the predicted value and the actual value. And the prediction deviations, the distribution of deviations. And we can see from the QQ plots in the -2 to +2 intervals, the deviation follows the normal distribution, meaning that the model learns the pattern very well for 95% of data set. So, and this figures shows that below 1 million, we can see the deviation is stable. But the reason is that our data set contains 95% of transaction below 1 million. And here's the P technology. It shows how that feature impact on the predictions. And we can see that when the crime rate increases, the price is sharply dropping down. So now it's about the implementation part. So you can see that we do the backend for the model in the Jupyter notebook. And here's we scrap the data from the website, such as some statistics information from government, and also they use a Google API to get the latitude for the property. Also the general models evaluation, also including the data processing, observation, and also how do we deal with, say, statistics information to make it from discrete to continuous. And here's some advanced deep learning technology, such as hybrid A and SVM, the BERT transformer. So I'll show you in the details. So here's about the random forest, specifically in the random forest model. So we made the analysis, the data relationship, the distribution, the predictions, also including the derivations. Also the data cleaning, the data filtering. Also about this is about the BERT transformer. So we implemented by the PyTorch, and we use the pre-trained BERT model. And because the transformer is about to deal with the neutral language models, but we can convert it into to fit our house pricing prediction data set. And here's the hybrid ANN. Here's about the mall models, about the linear models, the decision tree, random forest, also the data cleaning, data filtering. And here's also about the model, the log transformation. That's a scrap data from website. Also the statistics information. So we can see that the information is discrete, but our record is continuous. So how do we connect them? We try few methods such as the polynomials. So we will compare each and find the best one. And I think that's all for the implementation part. And thank you.
For the front-end part of this project, our team has adopted React 18 to develop our web application. React is an open-source JavaScript library for building user interfaces, primarily for building efficient and dynamic single-page applications. It is maintained by Facebook and widely used in modern web development. The library allows developers to create interactive UIs through a component-based architecture. In this project, we used React's declarative programming model to achieve component reusability and state management, ensuring performance and responsiveness, and delivering a smooth and engaging experience for users. Through this project, we can see React in action and how various technologies can be brought together to create a fully functional front-end application. First of all, let's start with our homepage. This page is made up of 6 different components, including a navigation bar component at the top, a search bar component, a line chart component showing the average house prices of different area in NSW, a detailed table showing the region data of different areas in NSW, and a footer at the bottom of the page. It is also clearly written in the code, as you can see from here. Next, let's look at the navigation bar at the top. It is displayed horizontally across the top of the app, providing users with navigational links to quickly access different parts of the site. Users are able to click the logo and it will navigate them back to the home page. At the right of the page, users are able to click the My Account button to be navigated to the login page if they have not logged in. Otherwise, it will pop up an alert window to confirm with the user if they want to log out. Below the navigation bar is our search bar. It is one of the core interaction components of the application, allowing users to enter a specific address or use a filter to get a list of the houses that they are interested in for the house price prediction. To achieve this, the component starts off by setting up several states, including handling user input, filtering parameters, selected attributes, and so on. It also uses useNavigate to handle page jumps and useRef to interact directly with DOM elements. The component also makes use of the useEffect hook to perform some actions on the first render, such as setting up Google address auto-completion and listening for selection changes. The effect is rerun when the search type is changed, after the user selects an address from the autocomplete list. The component parses the details of the selected location and initiates an API request to get the properties associated with that address. If a match is found, it updates the state to reflect those properties. Next, the handle search function handles user-initiated searches. If the user has selected an attribute, it navigates to a new page containing the details, otherwise, it logs an error message. When the user would like to use a filter to get a list of interested properties, the component allows the user to set multiple filters such as price range and square footage. Handle filter function is used to show the modal box containing these filters, and handle close filter modal is used to hide it. After finishing setting the parameters of the filter, users can click the search button to perform the search. The handle filter search function closes the modal box and constructs a query string based on the filter criteria, then navigates to the page displaying the filter results. The next two components below the search bar are a line chart and an information table. The line chart component is used to display historical trends in house prices on the home page. This is done by reading our back-end data and visualizing it as a linear chart by using an external UI library called ESChart. In this component, we use the useEffect hook to perform data fetching after the component is loaded. We fetch the data from our backend and then update our state, which is bound to the chart. This ensures that the chart is automatically updated when the state changes. The information table component shows some key statistics about the property market. These data are also come from our backend and are presented in tabular form by adopting the Material UI library. This component also uses the useEffect hook to initialize data fetching. The fetched data is stored in the state and used to render the rows of the table. We use the map function to iterate through all the data and render a table row for each entry. The last component at the bottom of the page is the footer. It uses the useLocation hook to access path information for the current page and the useParams hook to get routing parameters. This information is used to dynamically set the share text and links. It also provides the ability to share content on social media such as Twitter, Facebook and LinkedIn, each of which opens a new window with pre-populated shared content. Now, let's take a look at the property result page while users search for a specific address in the search bar. So, for example, let's randomly input an address that is in NSW. As you can see, the suggestions under the input are updated with continuous user input. After users find their preferred address in the suggestion list, they can click on the address to automatically fill in the rest of the address and perform the search. Here we are on the property result page. As you can see, this page has a responsive line chart to display the price of the property. A map display field showing the position of this property on the map. A recommendation field showing the other properties nearby with the similar area and price, and a historical transaction timeline showing the transaction record of this property. To achieve these, this component gets routing parameters via the useParams hook and uses them to request property data. It also uses the useEffect hook to get property details from the backend API after the component is loaded and store them in a state variable. Next, in order to create the responsive line chart below the address, similar to the line chart on the homepage, is also done by reading our backend data and visualizing it as a linear chart by using an external UI library. It makes the chart able to display historical and projected trends in property prices based on different time ranges. Thus, users can change the time range by clicking on different buttons on the top of the chart. Below the responsive line chart, there is a map field that displays the location of a property using the Google Maps API. Users can see a map with the location of the property and can click a button to view it in full screen mode in a new tab. Then, based on the currently viewed property, the system may recommend other properties. These recommendations appear as thumbnails that the user can click on to view details. Finally, the history transaction timeline is displayed at the bottom of the page. It displays a history of the property's transactions. By using the useEffect hook to trigger an asynchronous call that fetches historical trade data from a backend service or API. This data usually contains information about the date of the transaction, the price, the involved parties, and other relevant information. Each record is on a timeline, showing transaction dates and prices in a clear format,